and now let's start with his talk here about reparse points in SMB and how we can make use of them in Samba, and current status and some questions, some open questions, where to go and what to do next and so on. This all started out as under the umbrella of POSIX extensions. What are POSIX extensions? We have seen a lot of talks about POSIX extensions in the past few years at both sambaXP and also at Storage Developer Conference. Essentially, the idea of POSIX extensions in SMB3 is that we make SMB a valid competitor to NFS. Essentially, it's my personal goal to kill NFS, but that will probably not happen for the next 10 years or so. Hi, Tom. But from working for many years with storage OEMs, the question of protocol interoperability is always extremely difficult. Interoperability between local POSIX processes, NFS clients, and SMB clients with regards to locking and so on. I mean, it doesn't cause too many problems with customers, but only because customers are aware that locking between these different worlds doesn't work. So they have adapted their workflows to the missing pieces in interoperable locking. And so what I would like to do is just eliminate this whole thing by essentially pushing the responsibility for all this interop to the client and extend the protocol SMB so that the client takes care of the locking. And yeah, that's the idea behind this. What we want to do is extend essentially the SMB protocol, which I believe, I'm living in that world, but which I believe is a good protocol for file sharing, to extend this to make POSIX clients happy. How do they work as currently designed? As Tom has laid out yesterday, the SMB protocol is extensible, and we make use of this extensibility by doing negotiations. Hey, dear server, are you able to deliver POSIX semantics at very early stage in the protocol, at the so-called negotiate protocol request? We can ask the server, is the server able to do that? Server tells us yes or no, and then we can adapt our behavior. What are aspects of these POSIX extensions? One important one is file name handling. The general Windows semantics usually is that case sensitivity doesn't matter. So uppercase, lowercase, it's the same file. We have to deal with that in Samba and essentially fake that case insensitivity on top of a POSIX case-sensitive file system. That's one. Then in SMB, or rather NTFS, you have some reserved names. For example, colon is not a valid part of a path name. In POSIX, you would expect that you can have path names with colon. And there are some like LPT1 from DOS times that NTFS still doesn't like, that SMB still doesn't like. This is in SMB a thing that we can negotiate on a per open call with a POSIX create context. If you look at the protocol specification for SMB, essentially what it is when you open a file, and that's the only path-based operation that SMB right now has, when you open a file, then you can essentially extend the open call with an extended attribute, a new create context. So that means that on an individual per open call, you can say, for this open call, I want case sensitive, for this open call, I want POSIX, whatever. And so we are also using this POSIX create context facility to tell the server, hey, for this open call, we want POSIX behavior. What then happens is POSIX has some metadata that SMB can't really deliver. And what we do here is we have designed a new file information class. What is that? If a Windows client or an SMB client asks for metadata about a file, it just asks for so-called information level. And there's like a few dozen information levels. And we have carved out one additional information level for POSIX to ask for POSIX-specific information that we can't really get from, like n links. How many links point to an inode? I think SMB doesn't have that information readily available. I would have to look, but we have another information level that will get us the POSIX relevant information and be able to set POSIX relevant information in case it's required. However, this talk is not about any of this. It's about something that you can do completely without POSIX extensions. This page is completely missing one important aspect. Block special files, character special files, FIFOs, symbolic links, and sockets. What is that? If on a Linux client or if on a Linux system you do a make FIFO, you get a special file that has special semantics that is at this point in time not covered well over the generic unmodified SMB protocol as we know it. What of course is covered well is regular files and directories. I mean, that's the whole point of a file server, that you can create, read, write, delete, move files and organize them in directories. But none of the others are well covered at this point. And this talk will be about how I would like to handle these for Linux clients as part of the SMB POSIX extension effort. But mind you, I will have some demos here. None of this is really, I mean, I will open a Windows server here, unmodified, that does not, of course, have any POSIX extensions. So this works without. Where does Samba fit in here? Samba on this slide is meant as a server. So what we have is we have smbd, and the main point of smbd is it presents files and directories and all the other stuff to clients. And we do, of course, as I said, normal files and directories pretty well, and I believe pretty fast. But for example, if you test with FIFOs right now, if you do make FIFO and try to open this and write to that FIFO from a Windows client, it is a functionality that supposedly is supported by Samba. It's just broken at this point. Just because you can open it, it works. We didn't break that. What we did break is FIFOs don't like the pwrite and preread calls. They just say, okay, whatever, some error message I forgot. If you open a FIFO on a Linux file system, you can just write to it. And we eliminated from our VFS the write syscall. We replaced it with the pwrite syscall, which is a combination of please write this byte at that offset. And this syscall, pwrite, is not supported by pipes because pipes is always, it's a pipe. You can only write bytes. You can't give it an offset. And Linux at least doesn't support this. So, and nobody noticed. I mean, we don't have a bug. Pipes are not supported anymore, which tells me, well, maybe we can take this as an example and modify our behavior. Because, I mean, tell me, when did we remove read and write? I mean, 5 years ago? Yeah, so nobody noticed that we broke pipes by accident. Arvid is laughing. And so maybe that's an example that we could use to modify our behavior and present FIFOs as reparse points, because nobody is using them anyway. So we have sockets. We have some limited support for sockets, but for Unix domain sockets on the file system, but only in a very special use case as an endpoint, as a server-side endpoint for RPC service in a very special directory. So what you can do is you can create an RPC server or a general pipe server and run that as a daemon on your Linux machine, and then have Windows clients connect over the IPC $, the inter-process communication share, and that works. I mean, this is what we are using every day. But this is also only very limited, and you don't see these pipes as pipes on any client. You can use them, you don't see these sockets as sockets on the client. You can use them, but that's what it is. Then block and character devices. I mean, they just don't make sense on the client, or to handle them properly, to open them and handle them on the server. I mean, in theory, you could say, okay, I open a block device, IP write to it, NP write to the server disk, but no, you don't want that.
NFS has denied that for years. When you open an NFS block device, it's your local block.
Yeah. Tom's comment was that NFS has denied this forever, essentially, that you don't proxy your block device requests on the client. You have to take care of, I mean, if you have a block device exported via NFS, what it points at is your local USB thumb drive and not the server side drive. And with this, NTFS reparse points enter the scene. Who of you has actively looked at a reparse point, has created one or so? Jeremy has, Tom has, but I mean, usual suspects. It's really kind of an arcane corner of NTFS. And if you look at the doc help protocol support mailing list, I asked a question about a special error code, and Jeff McCashlin said, hey, well, this is not really supported. I said, yes, install the Windows server, and we need this NT-status IO reparse tag not handled properly, documented, and so on. And he said, hey, he pointed me at the right documentation piece, which is part of the doc help effort that Microsoft does, is I don't understand the documentation. There's two possibilities. Either I'm too stupid. The other way is it's a bug. And in this case is I was too stupid, but I still got an answer. So this shows me that reparse points are, it's an arcane dark corner of NTFS semantics, but it's a very useful one, as I will show here. So what is it? If you look at Wikipedia, reparse points provide a way to extend the NTFS file system. A reparse point contains a reparse tag and data that are interpreted by a file system filter driver identified by the tag. Let's digest this. Essentially, when you look at the data model, it's an extended attribute. It's just an XAttr. You have a file. You can, with a special IO control, you can set a blob that will present itself as a reparse point. And I don't have access to NTFS source code, but from my experiments, what reparse points actually are, when you want to open a reparse point, Windows goes through all of open code, it finds the inode, it finds the name, it does the access checks, and very late in the open code, right before returning to the client, it sees, oh, it's a reparse point. And what you can do apparently in the Windows server is you can install a driver that hooks into these reparse point tags that at open time and only at open time does special magic. And if there is a reparse, if NTFS detects, hey, we have a reparse point with a reparse tag, which is a 32-bit number, and if at open time it does not find a DLL that is loaded into NTFS, whatever mechanism that is, that would take care of this reparse point, it returns the error NT-status IO reparse tag not handled. You can't open the file because it gives reparse tag not handled. So if you look at MSFSCC, there's a few dozen reparse tags. Most of them are labeled as only used internally, not useful, not meaningful over the wire. This is not really strictly what it is. Essentially what this means is we don't document this. You can look at it. You can set arbitrary reparse points. I mean, you have to follow some formatting rules, but you can set arbitrary reparse points over SMB1 even if you want. But only if you happen to set a correct IO reparse tag, then you will trigger the magic inside NTFS. So, but I fully believe that most of these reparse tags, these few dozen ones, that they are only used really with local applications. I mean, if you look at the names, it's like some backup applications, some HSM tags, whatever. I mean, it's really just local stuff. However, I will come to Symlinks. Yes, Symlinks, you can store Symlinks there. Microsoft designed Windows Subsystem for Linux. And the version 1 had the same problem as we do. Version 1 of Windows Subsystem for Linux uses NTFS to store full POSIX file system semantics. And they said, hey, I have a FIFO, I have a socket, what do I do with this? And what the Windows Subsystem for Linux creators, the developers did, they invented reparse tags. I mean, in the end, it's a 32-bit field, and you, of course, have some way to allocate your bits, your IDs, or whatever, but they just took a few of these bits, like IO reparse tag, LX, block, FIFO, character, and so on for the obvious ones. For example, IO reparse tag, address family Unix for sockets. The problem is none of them are documented, and V1 of WSL right now is kind of deprecated. It doesn't really work well. V2 of WSL just creates a VM on a block device and uses local ext4. So the need for this is not there anymore with really actively supported Microsoft products. But then we have a different subsystem. Windows has an NFS server. And mind you, they have their own notion of, I mean, with NFS server, you have to create FIFOs, you have to create sockets and so on. But you would have thought that these guys talk to these guys and agree on a data format. No. And this is what I'm going to show you here. And Windows NFS server can present normal NTFS directories and files over NFS. And they, of course, also have to present sockets, block devices, and so on, all the others. And what they did, they also invented an IO reparse tag, NFS, to be used by the NFS server, also not meaningful on the wire. However, it's documented what's in there. Tom smiles. I can show you the documentation.
It's a glaring bug in the documentation, my opinion. But yeah.
You would call, Tom's comment was, it's a bug in the documentation that it ended up there.
No, that it's not fully documented.
It is documented. The NFS reparse tags are fully documented.
The word's not meaningful over the wire. That's the problem.
Okay, yeah. For example, if you look at how the NFS server stores block and character devices, it's just two 32-bit numbers attached to each other, which is a major and minor number, as you would expect. The Symlink has the target as a normal Unicode, and I believe, I haven't really tested, I believe it would be UTF-16 because that's what Microsoft sees as Unicode. And there's one little thing I want to show you here. So let me exit this here. What do I have here? I have a Windows server, and Alexander told me that you can't really read this back there. And my mouse is very, very sensitive here. So I installed the NFS server. And once you install the NFS server, you can have properties, and you see NFS sharing. I'm reading this to you, and I didn't find a way to make this larger. You can have this as NFS share. And what I did here is I mount this NFS share on Linux with NFS v4 apparently. And what you then can do is, of course, you can have a pipe, for example. I create a make FIFO new pipe. And you will see this new pipe from NFS as a pipe. You will see this, I mean, ignore the UIDs and whatever, I'm not interested in this for the moment. You will see this here as an NTFS file, new pipe. And I mean, it's, oops, if you want to delete this, let me try deleting this. You get an error message. An unexpected error is keeping you from deleting the file. If you continue to read this error, you can use the error code to search for help. I mean, this is the GUI representation of IO reparse tag not handled. And what they should have done is, in response to this, open with a special flag that they, yes, I want this as a reparse point, and delete it. That's a bug in the Explorer, essentially. Tom agrees. Yeah, but I just like this. So this means that reparse points are kind of an arcane corner of NTFS that not every GUI developer really takes care of. One more little nice thing is, I have two Symlinks here, and now I'm showing you the Symlink aspect. I will get back to those a lot later. This is a real Windows Symlink. I mean, Windows does have Symlinks. You have a make link command, you can create Symlinks. This is a real Windows Symlink. The Explorer shows it, and I could delete it now if I wanted to, but I have to keep it around for a demonstration. Excuse me. What you see here on the Windows client is the link was called, the real Windows Symlink is called LNK. It's shown as LNK here. Look at the L at the left-hand side, in the left column. But if you say stat LNK, the NFS server gives you an IO error. What instead, it has its own notion of a symlink. With its own reparse tag, it just can't deal with native NTFS symlinks, where it could. And this is also kind of a unknown territory to everybody here in the Windows world. Just get your act together and agree on something. And we have to, what I want to show you is we have to pick our ways anyway to do things. Okay. Where are we with my presentation? Here's my presentation. Okay, what do I have here? Yes, this is still the Windows. One more little thing that I want to show you just out of curiosity. I have a FIFO here. NFS created FIFO. And if I do right click, properties, details. Can you read this L here? So it says attributes AL. A for archive, to be archived, and L for, if you look up the documentation, what's L? It's a reparse point, but the GUI shows all reparse points as symlinks. L for symlink. Because that's the only reparse point that the Explorer knows about. Yeah, fun stuff if you go there. Okay. So, we have to make a choice now. I presented 2 slides ago that Windows Subsystem for Linux v1 had the problem to store FIFOs in the file system. They picked one set of IO reparse tags with undocumented contents, and I don't think anybody will document them because it's unsupported now or whatever, not developed any further. And then we have the NFS server, which is a fully supported product by Microsoft, which chose their own way to represent metadata for Unix. And so we have pros and cons. So WSL defines distinct reparse points per file type. NFS only uses one reparse tag, and inside the content of the reparse tag, they distinguish between what is this really. If you look at the pros that so we have to make a choice. Which data representation does Samba focus on? And pro NFS here is, yes, we have it documented. We can do protocol level tests with the Windows NFS server for whatever. We can just do the same. We can install an NFS server on Linux, do a make FIFO, and the test is, do we behave the same as Windows in the same situation? This is something I would like to do. Make FIFO on an SMB client, if you happen to have your NFS server, if we were to create a FIFO for NFS servers, we can, of course, do the make FIFO from an SMB client, just create the file, add the reparse tag, and so on. And the Windows NFS server would also present this as a FIFO to the NFS clients. I would see this as an advantage as well. There is one advantage when using the WSL format. If you do directory listing, as part of the query directory response, what you get is the reparse tag. And later on, if we want to fill our client cache, we need to know what type did we get in the read dir plus or SMB query directory operation. And if the client then later on does a stat, or the client application does a stat, then it wants to know, hey, is this a FIFO? They don't want to know, yes, it's a reparse point. When using NFS style reparse data, we have to do another round trip to the server to really know, is it a Symlink, is it a block device, is it a character device, and so on. We don't have to do this with the WSL thing. But still, yeah, Jeremy?
So one question, if you open the directory with a POSIX context and you're doing the POSIX info level, what will you get back as the file type? Let's say we use the NFS style. What would we get back in the file type mode bits?
So Jeremy's question was, if we ask for POSIX information in the query directory, this is all up to us. As I said, I'm talking about completely unmodified Windows servers here. This is completely up to us, and I would have to look at your patches, at your code. Yeah, but I mean, what the Windows server sees, the Windows server actually sees a FIFO, and it would be stupid to define a new info level for query directory and not pass this information correctly on. And I mean, we are still not really finalizing, or we haven't finalized the info levels essentially. So my guess, my approach would be, if a client comes in with POSIX information request, just pass them on the correct information. I mean, that's simple.
Do the local lookup of the reparse tag.
Yeah, exactly. So okay, we have two cases to distinguish here. One is Samba finds a real Unix FIFO on disk. It just can do a stat. Other cases, Samba finds a file where the attribute says, hey, I'm a reparse point. Then Samba on the server side, to present the POSIX information correctly, hey, this is a FIFO and not a block device. Samba server side then has to read the extended attribute that the client has set. There's two cases, but as both are server side, yes, for the Samba server, it's another syscall to get the extended attribute, but it's not a round trip on the protocol. So my vote would be use the NFS stuff just for the interop, sorry. Yes?
Is there not a third option, creating your own reparse point numbers? You should invent a new set.
The question would be just invent a new set of reparse tags. Yes, of course. This option is there. But why? I mean, yes, I mean...
Because then you can tweak the behavior as you like.
we can tweak the behavior as we like, but from my point of view, the behavior is sufficient. I mean, we could opt for the WSL, but as nobody really uses it, and if you create then a WSL style FIFO via your SMB client against a Windows, you can do that against a Windows machine. It will happily store the reparse tag, but the NFS server wouldn't understand that anymore. So, yeah, make choices. And my vote would be use the NFS reparse tags to present them over the wire. Symlinks. With Symlinks, we have yet another choice. We have three choices. WSL has their own Symlinks. NFS has a Symlink, we have seen that. And then there's native Windows Symlinks. And this is the place where I really learned about the special behavior that reparse points do in the NTFS space. Namely, that at open time, when you hit a symlink, you get a special error code in the create response. And I will show you that. So, reparse tag symlink is the only one properly interpreted by the SMB server that I know of. I mean, there might be others that are relevant to the SMB server, but I haven't found any yet. So, when you try to cross a symlink, so you have /a/b/c, and /b is a symlink, the SMB server will return to you NT-status stopped on symlink. And this is actually usable in the sense that it's in SMB1, this would be the end of the story. I stopped on symlink, do something. SMB1 wouldn't tell you whether it's /a/b/c or /d at the end of your path that you passed in, that is a symlink. So what you would have to do in SMB1 is go back to the server, do the steps by hand, and ask for the reparse pointness of all the path components. SMB2 has extended this with a special error information that tells you two things. First, /a/b/c, yes, /b is a symlink, and by the way, it points there. And this makes client-side symlink handling pretty simple because you get all the information just in the error response. And of course, Samba has to do two things. Samba has the case against, again, we find symlinks during our path walking server-side. And Jeremy has had very vocal talks about this, that we should never follow symlinks server-side. We can't really switch that off yet. But if you negotiated POSIX, for example, I would vote for, hey, never follow symlinks server-side, make that a default. But what we can do is we have the option to say follow symlink equal no as an smb.conf option. And in this case, we should just return stopped on symlink with the appropriate information. Excuse me. We have to be a bit careful about symlink targets. If they point out of our share, then we're dead. We can just present this, but the client will not be able to make any use of it. If it's inside the share, yes, of course, we can correctly manage this. If it's an absolute path inside the share, we could present this as relative or as absolute or whatever. I mean, there are details to really take care of. You can't just really pass on the information as the symlink. You have to be a bit careful about this so that the client can actually make use of this. But that's server-side interpretation, and my code doesn't really fully do that yet in all aspects. So if a client comes in and doesn't make symlink, and this is what I want to show you for and this is a predefined demo. It's just a Wireshark trace. Wireshark. So this is a Wireshark. Can you read this, or shall I make this larger? Ralph, in the back?
A bit larger, maybe. That's enough.
Okay. So this is a client creating a symlink. And let me This is Windows to Windows, by the way. Windows to Windows using the make link command. And it created a symlink. And the first thing the client does is it creates a file. And if you look at the flags, there is a hint that this might turn into a symlink as part of the create request, as part of the create options. Open reparse, no. Yes, open reparse point down here. So the client gives you a hint that this newly created file, this didn't exist, this might turn into a symlink in the next request, set reparse point.
I think it's setting open a reparse point in case that file already exists.
Exactly.
Right.
But this is, yes, but it's a hint. It would be entirely legal for the client to just create the file, close it again, open it again, and do the set reparse point afterwards.
It's a hint, but it's maybe not 100% reliable.
Tom's comment was that this is not 100% reliable, and that's the point I want to make.
Okay.
This is essentially a normal create a file, create a text file, create a whatever, Excel file. Only after the fact that the file was created, we get the, hey, this is a reparse point, this is a symlink. Oops, sorry, let's go here again. This is a symlink. Let's open the in data, reparse data buffer, and this points at target. So this is the make link command from target to link or link to target. I always get confused by the order of the arguments. But this creates a symlink with target, target. The question is, how would Samba deal with this? Ideally, or some could argue, let's make this real symlinks on server side. Let me repeat, no. Jeremy is getting vocal again. So, creating special files over SMB would be 2 steps. Just create a file, just create a normal text file, and then in the second step, that is protocol level second step, just set the reparse point extended attribute. And we have code for this. Jeremy has code for this. I put it into my branch here. So we should just do this as an extended attribute on a plain normal file. And this really matches what Windows actually does. So we can then do this the same, because I mean, for us, it's just an extended attribute, and the client can just query it again. We just do some general checks. Does this fit the reparse point tag? Is it more than 8 bytes for the reparse tag, and so on? And we have to return a special error message if the client completely messes this up. But essentially, it's just a blob, and the client can do whatever it wants. And this way, you can also just create a block device with, you can create a FIFO and so on. If you just allow, the problem is you see these server-side as normal files with an extended attribute. What we could, in theory, do is just have server-side tools that in this space you want to create this into something NFS compatible, because these FIFOs won't be visible to Ganesha and to the kernel NFS server. And if you have a use case, maybe do this via some whatever VFS object or something, but definitely not in the default case. If you really have the interop case, but this is what we want to kill with, we don't want interop anymore. If you really need the interoperability of make FIFO to be visible properly over NFS or to local processes, you need to do something server-side. But this is definitely not our first step. So what's the current status? Most of the server-side code of creating reparse points, returning anti-status, reparse tag not handled, returning anti-status stopped on symlink, it's already there. It's in merge request 2887, which I marked as draft because of all these questions here. The main question is how and when do we activate this server-side? And the main problem here is we don't have proper clients for this yet. And what we could do as an initial step is FIFOs are broken anyway, and as essentially a test or whatever, something so that we get something upstream, we could just return FIFOs as reparse points, and while there, just do the same for block and character devices. Not look at Symlinks yet. This might be one way, and what's incomplete is, I mean, SMB1 also does all this stuff. It's just an FS control that you can also issue over SMB1. So SMB1 also returns reparse tag not handled if you ask for it. This is incomplete server-side now. I wouldn't really care, but I mean, it's a nice completion here. What I'm doing is I'm working on libSMB client to include this for 5 minutes. To include this for user space clients like KDE and like GNOME VFS. This is my current work because this is what I can mess with. So and these are the questions, essentially the policy, how and under what circumstances do we enforce this upon users? And this is for the audience, for the Samba team, and we will discuss this later on, maybe on the list, maybe in this merge request or whatever. I would have to rebase the merge request upon for latest master and so on. But the server-side code for reading Symlinks, reading FIFOs as reparse points, returning the stopped on Symlink with the correct error message is basically there. You can set reparse points and so on. And with this, I'm done. Thanks for your attention.